Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to today's natural sciences lesson. My name is Papichezo Singo, and this lesson is proudly brought to you by the Harding Department of Education. In today's lesson, we are going to be learning under the knowledge area energy and change. The topic is energy transfer in electrical systems, and the subtopic is circuits and current electricity. Now let's go through the lesson objectives to find out our goals for today's lesson. At the end of the lesson, you should be able to define an electric circuit, describe a simple circuit, and investigate the flow of current using a simple circuit board. All this is sourced from the CAPS document on page 47 to page 48. Now let's go through pre-knowledge. So this is a trip to our past. Remember, in grade 5 and 6, you were introduced to circuits and current electricity. You also got introduced to energy and change in the 6th grade. Now let's move on to our baseline activity. So I'm going to read out the questions and then give you time to answer them. You can send in your solutions to the WhatsApp number that's at the bottom of the screen, 079 578 2908. The first question reads, define the following. 1A, static electricity. 1B, electric charge. 1C, electric discharge. Number 2, a sock falls from the washing line and clings to a wall. 2A, explain how this is possible. 2B, what makes the sock fall from the wall eventually. Take 5 minutes to quickly answer each of these 5 questions, and then I'll see you after 5 minutes. Welcome back, learners. I hope you're sending in your responses and any questions that you may have to our WhatsApp line, which is 079 578 2908. Now let's go through the solutions. Let's start off with the definitions. 1A. Define static electricity. Define static electricity. It is an electrical charge caused by the buildup of electric charges on the surface of an insulator of electricity. On the surface of an insulator of electric charge. Electric charge, it is the positive or negative property of a particle. And then C, 1C, what is electric discharge? It is the release of electric charge through a solid, liquid, or gas. For example, lightning. Take 1 minute to quickly copy down each of these definitions. Then after 1 minute, we'll answer question 2. Welcome back, learners. Now let's answer question 2A and question 2B. A sock falls from the washing line and clings to a wall. Question 2A read, explain how this is possible. This is possible because of friction. So the friction between the sock and the washing line causes it, meaning the sock, to become charged. So once it is charged, it falls off the washing line and then goes to cling to a wall. Remember last week when we were learning about friction and static electricity, we learned that charged objects do have an effect on neutral objects or other charged objects. And in this particular case, we can see sticking to the wall means that the sock became attracted to the wall. It became attracted to the wall, hence it stuck to the wall. Question 2B goes on to say what makes the sock fall from the wall eventually. So after being attracted to the wall, what makes the sock to eventually fall from the wall? It is electric discharge, the release of electrons. So from either a solid, liquid, or gas. Remember that is electric discharge. So electric discharge happens. So electrons are released from the sock, and then the sock becomes neutrally charged again. That's when it falls from the wall. Take 1 minute to quickly copy down these two, and then after that we will go on to terminology. 1 minute. Welcome back, learners. Now let's continue with our lesson. Let's move on to the first terminology slide. So we are going to learn terms that are going to help us better understand the concepts that we're going to learn in today's lesson. The first one is electric circuit. Electric circuit, this is the path through which electric charges move. It is a path through which electric charges move. And then electrical current. Electrical current is the flow of charges in a closed circuit. Conducting wires. This is the material through which electric charges can flow. So electric charges can flow through conducting wires. And then a switch. What is a switch? A switch is a device used to control the flow of charge in a circuit. The flow of charge in a circuit is controlled using a switch. Let's go through the second slide. A cell. What is a cell? A cell is a chemical system that stores electrical potential energy. What is a battery? This is two or more cells. So if it is one, we call it a cell, and then if it's two or more cells, then it ceases to become a cell, we call it a battery. So a battery is two or more cells forming a chemical system that stores electrical potential energy. Resistors, what are they? This is a device that tends to oppose the flow of current. A device that tends to oppose the flow of current. And then a filament is a very thin wire. Filament is a very thin wire. Now let's learn about circuits and current. Electricity. Now charges we know from our previous lesson when we're learning about friction and static electricity, especially electric discharge, that charges are capable of jumping over a gap between two objects. The charges are capable of jumping between two objects during friction when one object loses electricity and another electrons, when another object gains those electrons. Right, so electric charges can jump over a gap between two objects to cause a spark or a shock. But a path can be created for electric charges to move from one object to another, and this path is called a circuit. This path is called a circuit, which brings us to a simple circuit. Now, the flow of electric charge in a circuit is called an electric current, and a simple circuit consists of this is the following, it has a source of energy, so it needs to have a source of energy, and that source of energy is usually a cell. And then we also require conducting wires. So this is a special material or a material that allows charges to flow through it. So conducting wires are required for a simple circuit. We also need a bulb, and we also need a switch. A switch is going to control the flow of current, so it can either break it or allow current to flow through the circuit. So here is a picture of a simple circuit. We've got our bulb here, then we've got our wires, the conducting wires that allow electric charges to flow in. Then we have our source of energy, the cell, and the switch, which we can switch on and off to control the flow of current, Now, a circuit, we have said there is current flowing, there's charges flowing within a circuit. Now, a circuit is a system that is able to do what? To transfer electrical energy. So a system that transfers electrical energy is called a circuit. Now, the cell. Now that we know that the cell is our source of energy, the cell is our source of energy. What type of energy is it? So it is chemical energy. So that chemical energy that is stored within the cell is transferred to electrical energy in a circuit. So a circuit is a system that transfers electrical energy, and the cell, which is known as the energy source within a circuit, contains chemical energy, and that chemical energy within the cell can be transferred to electrical energy. So here we have our cell. There's our cell, right? So this cell contains within it chemical energy, and that chemical energy is transferred to electrical energy. We see it being it's transferred by electrical energy, and then our conducting wires allow that electrical energy to flow through them. Now, and then we have our bulb which will give us light energy, and heat energy, they tend to get warm with time. So you see within this circuit here, there is a transfer of energy from chemical to electrical, and in this particular case to light energy. Now electrical energy in the bulb. Electrical energy, is converted to light and heat in the bulb. So we started off where? We started off with chemical energy in the cell, which was transferred to electrical energy flowing through the conducting wires. And then when we got to the bulb, that electrical energy then was converted to light. You saw the bulb glowing, you saw the bulb shining, and heat energy. Now the cell, the conducting wires, and the bulbs, they work together. They work together to form a system that transfers energy. We've just talked about the different types of energy that we witness or we see within the circuit. We've got your cell that contains chemical potential energy. We've got your conducting wires that help to transfer into electrical energy. And we've got your bulbs. So how does it work? First, the energy source. Who is the energy source? The energy source is the cell. The energy source provides the chemical energy to the charges. Where are the charges? The charges are found on the conducting wires. There's our conducting wires. There's our cell. Let me just write conducting wires. Okay, so the energy source provides chemical energy to the charges in the conducting wires. So what's next? The charges use kinetic energy to move the electric current. So this is another type of energy, kinetic energy, energy of motion, energy of movement. The energy is transferred again to the device. If the device is a light bulb, we get light. We also get heat. If the device is a radio, we get sound. Or a bell, an electric bell, we get sound. Or an electric speaker, we get sound. Or any other type of energy. So a circuit is a system that transfers energy. So here are different appliances that use electricity for them to function. So we've got our air conditioner. It's got those, it transfers its electrical energy depending on the season. If it's a cold season like it is, we use our air conditioners to blow warm air to keep us warm, to keep our rooms warm. Then we've got a dryer, we've got a clothes iron, electric fan, a coffee maker, a lamp that will give us light. Of course, the iron will give us heat to iron our crisp clothes, the light bulb, the rice cooker. These different appliances are part of the whole transfer of energy. Now, electric appliances function because it is a circuit. Always know that it is a circuit. So, an electrical appliances function because the circuit is complete when connected to a power source, whether you are using a torch and you put cells inside the torch, or you are plugging in your kettle to a mains. It is a circuit, and once it is connected to a power source, it is a complete circuit. So a power source, there are different power sources. You've got your battery, you've got your cell, and you've got your electric mains. So these you plug to an electric mains. You can connect it to a cell or a battery, electric mains. So electrical appliances, they function because they are connected to a power source. Connecting to a power source completes the circuit, and then they are able to function. Connecting them to a power source completes the circuit, and then they are able to function. So what do we mean by complete circuit, open circuit, closed circuit? An open circuit is one in which an electric current cannot flow because the pathway is not complete. So for a circuit to function, the pathway has to be complete. There should not be gaps There should not be gaps in the pathway. The pathway must be complete. So when the circuit is said to be open, then we know that the electric current cannot flow because the circuit is not complete. A closed circuit is one in which current is allowed to flow. A closed circuit is required. A closed circuit is needed to make a device work, such as a torch bulb to light up. If we look at these two, here on the left you've got a closed circuit, and on the right you've got an open circuit. An open circuit does not allow current to flow. Why? There is this gap here. There is this gap over here. So the electric current cannot flow because the pathway is complete. The pathway is not complete. It is not complete. So it cannot flow. The pathway is not complete. Hence, our bulb is not glowing. The bulb is not glowing. With a closed circuit, the pathway is complete. Electric current can flow and the bulb is glowing. The bulb is glowing. All right, now let's do our first activity. I'm going to read out the questions to you and then give you time to answer them. Don't forget to send in any questions you may have or solutions to the WhatsApp number that is at the bottom of the screen, 079 578 Question 1. Label the parts of the circuit numbered 1, 2, 3 below. So we've got part 1, part 2, part 3. You need to give us labels for those. Number 2, which part of the circuit is the energy stored? In which part of the circuit is the energy stored? Number 3, what is the function of part 2? Take 4 minutes to quickly answer these questions. Then after 4 minutes, we will do the solutions together. Welcome back, learners. Now let's answer these three questions. Label the path of the circuit numbered 1 to 3 below. So, what is 1? 1 that is above. What is 2? 2, those are conducting wires. And 3, that is the cell. Number 2, in which part of the circuit is energy stored? Energy is stored in part 3, the cell. That is where energy is stored. What is it? It is chemical energy. Remember, we said it is chemical energy. And what is the function of part 2? What is part 2? Part 2, those are conducting wires. What is the function of conducting wires? They provide a pathway for electric current to flow. They provide a pathway for electric current to flow. What are conducting wires? So they're usually made from metals, especially copper wire, because they do allow electric current to flow through them. Now take 2 minutes to quickly copy down each of the corrections. Make sure also to copy down the circuit. Take 2 minutes. Welcome back, learners. I hope you had enough time to copy down each of the solutions. Don't forget to send in any questions you may have and the solutions to questions that were asked during this lesson to 079 578 2908. Now let's continue with circuits and current electricity. We know the components of a simple circuit where we have a cell. What is the function of the cell? Energy, electrical energy is stored within the cell. But the more cells that are connected, the greater the electrical energy that can be stored. So one cell, if we add another cell to that one cell and we add a third cell to that one cell, then we have a greater amount of electrical energy that we can be able to store. So 3, 4 cells are definitely better than 1. We have other components that we find within the simple cell. We have other in the simple circuit. We have other components that we find within a simple circuit, and they are all connected from one terminal of the source of energy along conducting wires. Conducting wires, like we said, we usually use copper wires because copper is a very good conductor of electricity. And then through the device can be a bulb. The device within the bulb, you find a filament which allows the bulb to glow or shine as well as get warm enough to also produce some heat. And then we connect back to the source of energy, the cell, completing the pathway. So to complete the pathway, this is the connection once again that we need. We need the components to be connected from one terminal of the source of energy, which is the cell. So the cell has two terminals. We've got a positive terminal and a negative terminal. So we have two terminals, a positive terminal and a negative terminal. If you look at a simple cell, a dry cell, the positive terminal is the one that has like a little knob or a raised part on one end, and then the negative terminal, that is the flat end. So the components once again need to be connected from one terminal of the source of energy, which is the cell, and then along conducting wires, which are usually made of copper. You will see in the investigation that I'm going to use conducting wires that have crocodile clips on the end, and through the device, which is the bulb, and back to the source of energy, which is the second terminal, completing the pathway. The pathway must always be complete. Now, a component, there's a special component that is used within a simple circuit, and that component is called a switch. What does a switch do? A switch opens and closes a circuit. Let's take, for example, a device such as a torch. A torch has a switch. You normally see the switch of the torch on the outside, but that switch plays a very important role in the pathway of the circuit. It opens and closes it. So a switch or a torch has a switch that opens the circuit so that there's no flow of charge. So then our torch is off. And then when you want to use your torch, maybe during load shedding, you will close the switch by switching the switch on. So in the case that the torch bulb does not give light, we know that the pathway is incomplete. The pathway is incomplete in the case that the torch does not give light. Now, when the switch is on, the story becomes different. Now there is a flow of electric charge. Now our circuit becomes complete. When the switch is on and the circuit is closed, then your torch bulb will give off light. So whenever the torch bulb is off, we know that the switch is open. If the switch is open, then the pathway is incomplete. When the torch light bulb is on, then we know that the switch is closed. The switch is closed, the pathway is complete, then electric charges can be allowed to flow. So now, grade 8, we are going to move on to our investigation. So we are going to the lab. We are going to be to the lab to build a simple circuit. So let's go to the lab.
Look at where you have been and ask yourself, am I happy with the results? Look at where you are right now and ask yourself, am I happy with what's going on in my life? What differentiates successful people from unsuccessful people, A students from average students, is the things that we do on an everyday basis. If you want to change your results, you need to take that one thing and repeat it over a period of time until it breeds results. And that is the art of consistency, because consistency breeds success.
Welcome to the lab, grade 8 learners. So now we are going to do our investigation for the day. So in our investigation, remember, we want to build a simple circuit. So what is our aim? Our aim is to build or to make a simple circuit. What are we going to use for our simple circuit? We're going to need cells, conducting wires. We're going to need these conducting wires, have to have crocodile clips on them. We're also going to require a torch bulb, and we're going to require a switch. So what are the steps that we are going to follow? This is our method. Here we go. First step, you need to connect the cells to the cell holders. So our circuit board has cell holders, so that's where we're going to connect our cells to. And then second step, we're going to connect a conducting wire from one end of the cell to one end of the open switch. So remember, our simple circuit has a switch. And then next we're going to take another conducting wire and connect it from one open switch to another terminal of the bulb. Then the fourth step, we're going to connect another conducting wire from one end of the bulb holder to the other end or to the other terminal of the cell. Then what we're going to do is, when we have set everything up, we are going to close the switch. So this is a diagram to basically represent what we're going to do. So we're going to have three conducting wires. We're going to have three conducting wires. One conducting wire is going to be connected from one terminal of the cell to one side of the switch. The second conducting wire is going to be connected to one side of the switch, to one side of the bulb, and then the third conducting wire will be connected from the bulb to the other terminal of the cell. Right, so here is our apparatus. We have our apparatus over here. So these are our cells. They're going to be our power source. This is the switch. So this is the switch that we're going to use. And then this is the bulb. It's a small torch bulb. Then we have our three conducting wires with the crocodile clips at the end. So we're going to use the crocodile clips to clip on these knobs here. So first things first, we're going to connect our cells. Right. Okay. So cell number one. So the positive end is going to be on the right, facing the right, and the negative end is going to be facing the left. Cell number two, cell number three. Right. So here's our first conducting wire. Right. So our first conducting wire, we said, is going to be connected to one end of the terminal. So this is our battery. Remember, more than one cell is a battery, all the way to this end. Okay, so where are we going to place our switch? This is where we're placing our switch. Then our second conducting wire, we're going to connect our second conducting wire from this end to this end. What are we connecting next? Our bulb. There's our bulb. And then lastly, conducting wire number three, from this end to that end. So now the switch is open. As you can see here, the switch is open. It is not closed. So which means our circuit is incomplete. Our circuit is incomplete. So what happens? Now let's do our observations. We closed our switch. The bulb switches on. We open the switch. The bulb switches off. I'm going to do it again. Close switch. Bulb switches on, open switch, bulb switches off. Now, let's record our observations. So what are our results? What did we see? What we saw is that the bulb switches on. These are our results. What can we conclude? We can conclude that when the circuit is complete, current will flow. Current will flow and the bulb will switch on. When the switch is closed, current will flow and the bulb switches on. When the switch is open, which means our circuit is incomplete, the bulb is going to switch off. All right, now let's continue with our lesson.
Excellent. Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you're gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence.
Welcome back, learners. Welcome back. So now we are going to do activity number 2. I'm going to read out the questions. Question 1. The diagram below shows the battery of a mobile phone being charged. There's the diagram. 1.1. Which energy transfer takes place in the battery as it is being charged? 1.2. When the battery is fully charged, the mobile phone is unplugged. Which energy transfers will take place when the mobile phone rings? Number 2. What is the function of switches in a circuit? What is the function of switches in a circuit? Take 5 minutes to quickly do this activity. Then after 5 minutes, we are going to answer the questions together. Welcome back, learners. Now let's answer the questions. The diagram below shows the battery of a mobile phone being charged. So we've got a mobile phone here, so we've got the battery charger. Then we have the mobile phone that is containing the battery. So the battery of the mobile phone is inside the mobile phone. Question 1.1. Which energy transfer takes place in the battery as it is being charged? Which energy transfer takes place in the battery as it is being charged? It is electrical to chemical. So this is our way we get electricity. Remember, we said there are different kinds of sources. We've got a cell energy source, and we've got a battery energy source, and we've got a mains. In this case, the battery charger is connected to a mains. So electric charges will flow through this conducting wire. So they are flowing in the form of electrical energy. And then once they get to the battery, which is within the mobile charger, they will be stored as chemical energy. So it is electrical to chemical. 1.2. When the battery is fully charged, the mobile phone is unplugged. Which energy transfers will take place when the mobile phone rings? So, the scenario has changed. We are done charging the mobile phone, and then we unplug the mobile phone from the battery charger. So now the mobile phone has been unplugged. Then what happens? What happens next is the mobile phone rings. So what kind or which energy transfers have taken place in this particular case? It is chemical. Remember, energy was stored in the mobile phone battery. So energy was stored in the form of chemical energy. And then for the phone to ring, there had to be some transfer of energy to electrical and then sound, which is the sound that you're going to hear as the mobile phone rings. Question 2. What is the function of switches in a circuit? So we have this component. This component is called a switch. What is its function? So switches are used to control the flow of current. So they control the flow of current within a circuit. How do they control it? So when it is open, it breaks the circuit, which means current cannot flow. And when it is closed, current can flow. So that is how switches control the flow of current. Remember, in an investigation, when I would close the switch, the bulb will glow. When I open the switch, the bulb will switch off. So that is how switches control the flow of current in a circuit. Take 3 minutes to copy down these corrections. Then after 3 minutes, we are going to wrap up our lesson. Welcome back, learners. Now let's wrap up our lesson. What did we learn today? We learned that a circuit is a system for transferring electrical energy. We learned that energy can be transferred from chemical to electrical to sound, like in the example that we had in the question which was in the previous slide. Now, a circuit is also a pathway through which electric charges move. So it offers a great way or a pathway for electric charges to move. A closed circuit is needed to make an electric device work. Remember, a circuit is a pathway. So if the pathway is complete, then the electric device is going to work because the electric charges will be able to move from the source of energy all the way through all the components and back to the source of energy. So the pathway is going to be complete. We need it to be complete in order for a device to function. Now, the basic components of an electric circuit, which is a simple circuit, we require a cell. What does the cell do? The cell is our source of energy. So a cell or a battery will provide us with energy. We need the conducting wires. Why do we need conducting wires? We need a material that allows electric charges to flow through it. And the most popular are copper wires. They allow electric charges to flow through them. It is, after all, a very good conductor of electricity. What else do we need? We need a switch. What does the switch do? The switch controls the flow of current. A closed switch will complete the pathway and allow current to flow. An open switch will give us an incomplete pathway, which does not allow current to flow. We also need a resistor. In our case today, we used a bulb. Which shined when the circuit was closed, and when it was open, it switched off. Electric circuits can be represented by circuit diagrams. As you saw, we had quite a number of diagrams that help us to better understand everything and anything about circuits and current electricity. So we can represent them in diagrams. What does a complete circuit mean? A complete circuit means closed circuit, which means the switch is on. An incomplete circuit means open circuit, which means the switch is off. So when you switch off that switch by the wall, the lights go off, doesn't it? So when those lights go off, it means now the circuit is incomplete. That's why the lights in your bedroom, in your kitchen, and in your lounge would have switched off. When you switch that switch on, light comes on in the room. It means the circuit has been completed. Current can flow nicely. Means the circuit has been completed. Please do send in any questions that you may have to our WhatsApp number 5782908. I'm looking forward to receiving any questions or any solutions that you may have in line with today's lesson. Now here is the homework activity. Draw the circuit symbols for the following components: A, a cell; B, a closed switch and an open switch; C, a bulb; D, conducting wire; and E, resistor. Number 2, explain how a switch controls the flow of charge in a circuit. Take 3 minutes to quickly copy down each of these questions. Then after 3 minutes, we will end our lesson. Welcome back, and thank you so much for joining me in today's lesson, and I hope to see you in the next one. Goodbye.